Use the log properties to simplify. So remember we said that if the bases match, then they cancel and give you just the argument. So A and A match. So you get X. So in this case, we have a 6 and a 6. So this would become just 17. And that's it. All right. Number 20. This one's use the one-to-one for a log equation. So since the bases match, there's another property we said log A of X equal to log A of Y. That means that X will equal to Y if you have an equation and the same bases. So here we have the same bases. So you can say X plus 1 is equal to 3. Subtract the 1. X is equal to 2. Now, remember the one-to-one property only works for the simple type of questions, but I'm just doing it because I have a couple on here. I prefer you do the other way that I showed you, which we'll do in a little bit. Any questions on the first couple of problems here?
Oh, what if the exponent is the same as the base? Can that happen, or?
The exponent?
Yeah.
Yeah, like you mean like it's inside the log?
Yeah.
Yeah, that's another property that says log of A equal to 1, or log A of A to the X cancels out and gives you just the X. All right, let's move on to 22. So make sure you have all your log properties handy. So use the properties of logs to simplify. So ln of 1 over e squared. So first step, use the quotient rule right here. Ln of 1, it's going to be 0. Ln of this would be 2. Because these will cancel. Right? Remember we said log A to the A cancels. So ln and e are the same base. So they cancel. Any logarithm at 1 will be 0. Any base.
So I guess we have to make it 0 before canceling the bases.
What do you mean?
We cannot just cancel and leave the 1. We have to make it the 0, I guess so.
Well, you have to first separate this. You could have, if you wanted to, you could have done this if you wanted to. ln of 1 over e squared, that would be the same as ln of e to the -2, and then cancel that.
Right.
Which is the same, right, as this. As long as you use legit properties, you'll be fine. Just make sure you do it correctly. 23 is the same thing. So let's move on to something else. 24, I know it looks kind of hard. Use log properties to expand the expression. Log base 4, 11b squared c. So you have 11 times b squared times c. So this is 3 products. So the first thing you should do is a product rule on each factor. Right? At that point, we're pretty much done, but we have a power, so bring down the power. So that'll be, this will stay the same. This would stay the same. And that's it. It's completely expanded. Do you have any questions on this? Okay.
But yeah, I guess we use like 2 properties basically, yeah.
What's up? Yeah, we just used
Yeah.
the product rule once. So we had 11 times b times c, right? So we apply the product rule and change each product into a sum. And then power rule on this middle one. So the next one uses the log properties to combine the logarithm. So log x minus 5 log y plus 9 log z. So first thing we should do is apply the power rule. See how there's a power and a power, a coefficient? Because you can't do the quotient or the product until you have all the numbers in front move to the top.
And y is the verb.
Hmm?
And why do we have to move them to the top?
It's just the order operation. So you have to, because if you remember the product rule, right? It doesn't have, you can't use a product rule when there's numbers in front. Product rule shows them as simple logarithms, right? The original log product rule said log base a of x plus log base a of y is equal to log base a of x times y. There's no numbers in front, right? So use the power rule first right here to move those powers. And then apply the quotient and product rule here. So we have a difference. So that would be quotient. Now we have a sum. So apply product rule. And that's it. It's completely combined.
Is it okay if we write those rules on our formula sheet?
Yeah, please do. Have the quotient product, all the log properties, all the exponential properties, bring them with you. I'm not gonna make you memorize it. Okay, so
Sir, on
Mhm.
that log x minus log y5, is that going to be negative anywhere on that fraction or not?
this question here.
Yes.
The minus is on this part, so that's the part that's gonna go on the bottom.
Oh, so it changes. Okay.
Yeah, so the subtraction is a quotient rule. So when it turn into a fraction, addition is a product, so they turn into a times. So this times this is this here.
Gotcha. So like on number 24, when it's saying expression as a sum, difference, and or constant multiple,
Mhm.
if it's going to be a difference, that's only if it's going to be, say, for example, like that 11 negative b squared plus c or something like that.
You would only get a minus if you're going from here, if you're expanding something.
Right.
If you start with a fraction, then you're gonna have a minus somewhere. Like
Okay.
if I was expanding this one right here,
Uh-huh.
this would go back to this, right?
Okay, because it's coming from the denominator. Y5 is coming from the denominator.
Right.
So it would be, okay. All right, I got you.
Does that make sense, or do you want to see an example?
Yeah, could we see an example? Nothing too hard or
Yeah, let's do one just real quick. Let's make one up. ln of, let's say, x over x times y over z, right? So the first thing we should do is deal with the whole fraction. So xy is the top part minus the bottom part. So this fraction became, this quotient became a difference.
I got you.
And then a product becomes the sum, right? That makes sense?
Yeah, that makes sense. Thank you. Appreciate it.
Okay. 27. Solve for x. Okay, so here we have log base 2 of x equal to 5. So remember we said in order to cancel a log, you need to have the base of 2. So basically just write 2 and change this into a power. Then these will cancel, leaving me with just an x to the 2/5, which is what? 2 times 2 is 4, times 2 is 8, times 2 is 16, 32. Any questions on 27?
So you put the 2 on the other side.
What's that?
You put the base 2 on the other side, and that's the base of the 5.
Yeah, so you just introduce a base. So these become the exponents. And you choose whatever base you want. And I'm choosing the 2 to cancel the logarithm on purpose.
So do we always want to try to cancel the logarithm, or it's optional?
Yeah, well, we have to remember, what are we doing, right? We're solving for x, and the x is trapped inside a logarithm.
Okay.
So you have to cancel the log to get the x out. All right, let's do another one. So here we'll have solving an exponential equation. We need to solve for this x. So in order to bring a power down, you need to introduce logarithms. So this time we're going to do the opposite. So first step, divide by 2 on both sides. And we get to here. Once there's nothing in front, introduce a logarithm of your choice. I like ln, so there it is. Then bring down the x on purpose. Now we can divide this out and we're done. So x will become ln 4 over ln 5. Is there any question on this?
And so we can simplify that further, or no?
No, that's it. As far as you can go. You can get a decimal if you want, but this is the exact solution.
So I guess it doesn't matter. So if we use the log, the natural log, and you still get the same answer.
One more time, sorry.
Looks like it doesn't matter if you use the natural log or the normal log with base 10, you still get the same answer.
Correct. That is true. And that's proven using the change in base formula. Okay. You guys cool on 28 then? All right. $29 is another one. This is kind of the same. Let's do 30 instead. So I'm just going to put solve. That should be apparent whenever you see an equation. They want you to solve something, right? Okay. So 2 to the x and then 3 to the x squared, or if you prefer, 3 to the x to the 2, which is weird, but whatever, right? First step is introduce any log of your choosing. Then I'll bring down the x. And bring down the power here. Interesting. Subtract the x. I'm gonna subtract this over here. So I have x squared ln 3 minus x ln 2. So you get x ln 3 minus ln 2. Hold on a second. Let me see. Is there a solution to number 30? Nope. Oh, I see. This is what we can do. Sorry, it just looks so weird that I got confused. So remember, if we go back to basics, right? Yeah, when you have a quadratic, you set it to 0, which we did. And then to solve a quadratic, you factor. Once you have factor, you set each factor to 0. So we should never forget the basics. Right? Now
And
solve.
again, we divide, or what do we do? Or
Yeah, this is just like seeing a 3x. Right? This is just some number times x. This is just some number. So move that number over here and divide this out. So don't let the way it looks mess with your head. It's the same thing you've always done. You move the number over and you divide this number out, right? So we have two solutions. We have x equals 0. And we have x equal to this weird number. Any questions on number 30?
I guess we have to pass it to the other side because it's equal to 0.
You mean on this part?
Yeah, we cannot do the quotient rule because it says equal to 0 first.
Well, you can't you can't do the quotient rule. Well, remember, we're solving for x. That's the goal. The quotient rule will not help you solve for x because first you to do the quotient rule you'd have to bring the x up, and then you would combine them again. So then the x would be trapped up top again, which would not help you at all. So we're isolating x. That's what we're doing.
Is that answer acceptable? ln two over ln3?
Yeah, that's good for me. I'm not gonna force you to give me a decimal or anything. It's good enough. If you want to punch in your calculator, you could give me a decimal if you want to, but what matters to me is showing your work and just getting to an answer.
Could we just write it out as ln2 and ln3 without it being like a fraction? Or
How do you mean?
when, like, so when we write out the answer, could it be x equals ln2 and then equals ln3 or something? Or
No, this is one answer right here.
that's one. Okay.
Yeah, this is a number. This is like the number 3.5, or I don't know what it is, some decimal.
All right.
Man, you can't separate. You can't. They're not two different ones, right? Here, let's punch it in just so we can see, because I know it looks funky, right? But these are just numbers, like number 2/3. So ln, where's my ln button? ln2, oops, divided by ln3 is 0.63. That's all it is. So x is equal to basically 0.631.
If we do write it on decimal, do you want us to round it off to the nearest third decimal point or something? Or
Yeah, like 2 or 3 decimal points is fine, but as long as you show your work, it doesn't really matter too much. It's not a huge deal. Like if you're off by a little bit, I'm like, well, if you show you know what you're doing, like you show use your properties, you're good. Any other questions on 30? Okay. $31 is another is a log equation. When you solve log equations, you do have to check your solutions. So here you want to use your log properties to combine everything into a single log and then cancel the logs. So here we have a difference. So apply your quotient. And once you get to here, you could use the 1-to-1 technically, but I want you to get used to using a base. To cancel the logs. So then we get x plus 1 over x minus 2 equal to x. Multiply both sides by x minus 2. So these will cancel, right? Don't forget. X times x minus 2, that'll get us to x plus 1 equal to x squared minus 2x. Right? Set this equal to 0. Subtract these two terms over there. That'll get us to x squared minus x. No, sorry, minus 2x minus x minus 1. So x squared equal 0 equals x squared minus 3x minus 1. Okay. Does not look like it factors pretty at all. Double check everything. Nope. Life sucks. Okay, so you have to do quadratic formula. But something that you could do to save yourself some time is say, you know what, let me graph it first and see what are the solutions. If you have a graphing calculator, you can just check yourself. I'm not saying you need one, but so it looks like the solutions exist. So I'm going to go ahead and solve it. Okay, so quadratic formula. You go to negative b plus or minus the square root b squared minus 4ac over 2a. So that would be equal to negative 3 plus or minus negative 3 squared minus 4 times 1 times c 2 times 1. So negative 3 is a positive 3 plus or minus square root of 9 minus 4 times negative 1, that would be plus 4 over 2, which is 3 plus or minus the square root of 13 over 2, which will be x equals, once you punch, you're gonna have to punch this into your calculator, 0.303 and 3.303. So the only question is, can I use those solutions? You should see right away that you cannot use the negative. Right? If you plug it in here, I cannot plug in negatives to logarithms. So you should see that this solution doesn't work. So a quick way to check is just plug it in your calculator, right? Just see, okay, well, what is ln of negative 0.303 plus 1 minus ln negative 0.303 minus 2, and I get an error. Can't do it. Anyway, that's one thing you could do if you want to. Just plug in your calculator and see. You have to do it to both sides, of course, but as soon as you see an error, you can stop. So this one works. Let's see.
So it has to be positive or
The result inside any logarithm needs to be positive. So when you plug it in, if it results in a negative, you can't use it. But always check both solutions to be safe. So plug this one in and make sure it's equal. But the negative is usually not going to work, but you need to check. About 80% of the time, if it's negative, it's not going to work, but you have to check. Okay. I don't remember. Did we do any interest problems together?
I think we've done a few practice ones through the homework assignments,
Okay.
but not in depth.
Yeah, I think I gave you like 2 formulas, right? So let's look at 33. So just a quick recap. Continuous interest is A equal to P times E to the RT. Compounded interest is the A is the future amount. That'd be equal to P times 1 plus R over N to the NT. And I remember I told you that P is principal. Forget, I think it's this one. I don't remember. A is future value. R is rate. T is time in years, always in years. N is the number of times you compound. Pound per year. I believe that's everything. E is a natural number. It's just a number. Okay, so question 33 says that $1,000 is invested at a rate of R equal to 0.025 compounded continuously. So as soon as you see the word continuous, that means we should use the top formula. Okay, so they told us that, and then they ask us on part A, find the time required to double your money. Okay, so $1,000 is the principal. Then they want to know when you get double. So basically this is what they're saying. P is 1,000, and they're saying, well, what happens when you get to 2,000? When does that happen? And they said that given this rate, how long does it take to get there, right? How long, what's the time? So you're gonna have to figure this out on your own. Knowing that I started with this, double is obviously that. This rate was given. So put it all together. 2,000 is equal to 1. Well, let's write the formula down first. A is equal to P times E to the RT for the continuous formula. This will be 2,000 equal to 1,000 E to the 0.025 T. Solve for time. So divide both sides by 1,000. This becomes 2. Okay, now let's solve for T. So introduce ln on purpose to cancel the E. So ln2 is going to equal 0.025 t. So last step is divide by 0.025, 0.025. So this is going to be, t will be equal to this. This is how long it takes to double your money at this rate using a continuously compounded interest rate. All right, so let's find out what that is. So it's about 27 years at this rate, making no deposits. It's about 27.7 years. Which is not bad, I guess, if you're not, it's not just sitting there. So who cares? Although making monthly payments over 30 years gets you a lot of money. Okay. Any question on 33?
So we just plug in the t to the equation. The 2000 equals 1000 e to the 0.025, and then we just plug in ln2 over 0.025.
Oh, you're asking where this came from?
Yeah.
Oh, no. All you got to do is this.
Or just divide it.
Yeah, just change this to a decimal because this is a weird number, right? So divide ln2 by 0.025, you'll get 27.7.
Oh, okay, cool. And we can use our graphing calculators, right?
Yeah, that's fine. But
Okay.
scientific is good enough. Either one. You're required to have scientific at least, but I don't mind if you have a graphing.
Okay.
Any other question on 33? All right, 34 is composite functions. So the last two questions are about functions. He wants us to find fog, goth, and gog. Given that f of x is equal to negative 2x and g of x is equal to x plus 9. So fog will equal, fog means, right? F of g of x, which will be f of x plus 9, which will be negative 2 times x plus 9, which gets us to here, negative 2x minus 18. All right. Part B. G of f means g of f of x, which means g of negative 2x, which means negative 2x plus 9, which gives me this guy. G of G well, that means G of X, which is kind of weird, but it's doable. That means G of X plus 9, which means X plus 9 plus 9. Right? Any questions on A, B, or C?
So we're plugging the G into the same G, okay.
Yeah. So you take the X plus 9 and you plug it into this X. All right. You guys cool on 34. All right, last one. 35. You could do this in two different ways. So determine if f of x has an inverse. So f of x is equal to 9x plus 8. So you could just show that it's 1-to-1 and say, well, since it's 1-to-1, then it has an inverse. Or you can find the inverse. So remember how the rule said was step 1, change f of x into y. Step 2, change the x's and y's, swap the positions. Step 3, we said solve for y. So we're gonna subtract the 8 first. Divide by 9. And that's it. Step 4, change y into f inverse of x. So f inverse of x is equal to x minus 8 over 9, which is the same as x over 9 minus 8 over 9. Just in case they write it different. It's the same thing. So you can find the inverse and say, well, I found it, so it exists. Or you can show that this is 1-to-1 by graphing it, right? Because we said it is 1-to-1 if it passes the horizontal line test, which it does. You guys have any questions about your homework or about today's stuff? All right, well, we'll stop here. If you have any questions or concerns, feel free to stick around. I'll see you Tuesday for a new chapter.
See you Tuesday.
See you Tuesday.